Welcome back, guys. How are we doing? We are working through Unit 2 still, Section 2, and we are still in the land of writing and translating these equations. So again, I've got another big idea for you, and we're talking about saving money, and you can determine how much you will have after a certain period of time if you know the original amount and the interest rate for the period of time. You can also determine how much someone had at the beginning if you know the final amount, the interest rate, and the time period. And think about how all those things factor into setting up an equation to determine how much money you would put in the bank, right? So we're thinking about how we can work backwards to figure out the original amount or use the original amount to determine our final amount. And that's, again, all about writing these equations. So let's jump in. Our first example is all about Corey and his friend Walter. And they go to a movie, and each of their tickets cost the same amount. And they also decide to spend $5 on frozen yogurt. The total amount they spend is $22. So we are going to write an equation that describes this situation for Corey and Walter. And my first question for you is, what word tells you that the relationship describes an equation? There is one word in this whole paragraph that says this is going to be an equation. The word total gives it away that we are going to combine everything we spent at the movies, and we can set it equal to that total of $22. So the word total tells you that not only is it an equation, but also what operation do you use when you are finding the total of something. So think about if you ordered a bunch of hoodies and t-shirts for your soccer season and warm-ups, and how would you come to the total? So you would have to add together all the things you spent money on, right? So a total means you're going to find the sum. Now, looking at our paragraph, okay, looking at our description, what are the things we already know the values of? Do we already know the ticket price? Like how much Corey's ticket was, how much Walter's ticket was, the total cost, the yogurt price, or the total ticket cost? So we know the total cost was $22 for both of them to go. We also already know they spent $5 on yogurt. We do not know how much each ticket was. We also don't know how much they spent total on tickets. So I'm just giving myself some more room here. I'm going to translate this sentence into kind of a verbal description. So twice the cost of the tickets, right? We bought 2 tickets plus the cost of yogurt, or their frozen yogurt, equals the total. So now which of our equations here represents that verbal description? And I'll label them A, B, C, and D. I'm going to zoom in a little bit for you. So which one accurately depicts this sentence? Twice the cost of tickets plus the cost of yogurt equals the total. And you should have selected option A, because 2 times T would be the cost of the tickets plus the $5 on yogurt equals our total 22. Now, before we get to our next few examples, I want to review or refresh our distributive property. And the distributive property says that if we have a number like I have here, number 3 on the outside of my group of parentheses, I can multiply that 3 times the 2 and the 3 times x. So I could use distributive property to make this 6 plus 3x. And we're going to use that distributive property to help us solve some of our next few equations. And our first example we're going to work with is Mari, Carlos, and Amanda collecting stamps because they are the coolest people. And we know Carlos has 4 more stamps than Mari, and Amanda has 2 times as many stamps as Carlos. All together, they have 100 stamps. We want to find the number of stamps each person has, and we are going to represent the situation with an equation and then solve it. So going back to my description, I'm going to make a note of a couple of things. For example, I know all together is 100 stamps. So for my total, I'm going to write 100 stamps. I also know Carlos, I'm going to write just an example for Carlos. He has 4 more than Mari. So 4 more would be 4 plus, and I'm just going to put an M for whatever Mari has. I'm also told that Amanda has 2 times as many as Carlos. But because I don't know the exact amount for Carlos, I'm going to replace his name here with what I know his is equal to. So instead of 2 times Carlos, I'm going to write 2 times 4 plus M, because 4 more than Mari is how many Carlos has. And then for Mari, I'm just going to put an M. My goal is to set up an equation, and I know all 3 of these people together add up to the total 100. So I'm thinking in terms of a verbal equation, I could write Mari plus Carlos plus Amanda equals my total. And now I'm going to switch out their names for what I wrote that they are equal to. So Mari gets an M, Carlos is 4 plus M, and Amanda is 2 times 4 plus M. And I also already know my total is 100. And now I'm ready to solve. So what I'm going to do is first, using my order of operations, I need to multiply. I need to do that distributive property here. So I know 2 times 4 is 8 plus 2 times M, or 2M. And I'm just going to bring down the entire rest of my equation. And now I'm ready to simplify. So what I want to look for on the left side of my equation are my like terms. So anywhere I have an M, I'm going to combine them. So I have a total of 4M. And then I can combine my constants or my numbers. So I've got 4 and 8. And my total is still 100. Oops, 4 plus 8 is not 8, it is 12. Now solve your equation. We're getting really good at these, so take a minute and solve and see what you get for M. So first step would have been subtracting 12. And last step would have been divide by 4. So M equals 22. So now I want to go back to my question and figure out what did I actually just solve for. All I know is that Mari has 22 stamps. I only solved for Mari. But I want to know how much for each of them, so I'm going to plug that 22 in. And so for Carlos, I'm really doing 4 plus 22 for a total of 26. And for Amanda, I'm doing 2 times 4 plus 22, or 2 times 26, which is 52. And I can check my work by adding these all up together, and I confirm that I've got 100 stamps. So Mari has 22, Carlos has 26, and Amanda, the winner, with 52 stamps. Now, in context of what we just talked about with Mari, Carlos, and Amanda, had we gotten a fraction for our answer, would that make sense? And we wouldn't want to have a fraction as an answer because it doesn't fit with what we're talking about. So make sure you're checking your answer in context of your problem. So if you need to round to a whole number, make sure you're rounding to a whole number. All right, here's the one you are going to solve on your own. I'll get you set up a little bit though. We have a garden fenced in on all sides with 260 feet of fencing. We know that the garden is 6 feet longer than it is wide. We are going to solve for both the length and width of the garden. So I know all the way around is 260 feet. And that's another way of saying my perimeter. So the perimeter is the same thing as the sum of all the sides. So in my diagram here, I only have 2 of my sides labeled, but the width is going to be a W on the other side, and the length will also be W plus 6. So if I'm setting my whole thing equal to 260, which is the perimeter, 260 is the sum of all the sides. So I have W, a W plus 6, another W, and another W plus 6. So now you take over and try to solve. Hopefully you combined your like terms. So you get a 4W plus 12, all equal to 260. Whoops. Your next step would have been subtracting 12 from 260 to get to 248. And your last step should have been dividing by 4 to get to 62. Now remember, we're solving for both length and width, and 62 is only the width, so we need to plug that in for the length and say 62 plus 6 to get 68. And we make sure to have units in both of our answers.